Hi, so I'm Jim Goff from the London Java community. I'm going to introduce the Java 8 datetime API. So just briefly going to go through what Adopt2JSR is and why I was involved in this in the first place. We'll discuss what's already in Java 7. Then we'll look at some new things, how you work with datetime, some parsing and formatting examples, how you can interoperate with Java util.date, and then we'll look at some advanced queries as well. I'm part of the JCP group on the LJC that was elected onto the JCP committee around 3 years ago now. The JCP is a mechanism for standardizing technical specifications for Java. So this is one implementation that's gone through the JCP process to reach its final state. We launched an initiative called Adopt2JSR, and this was the pilot for Adopt2JSR. The program generally is to encourage members of the Java community to get involved with JSRs. It's also to evangelize JSRs to the wider community in order to increase participation. And you can find the project on java.net. So Java Date is in the language right since the beginning of launch of Java. And you know what, there's many good discussions about what was wrong with the current implementation that you can go away and take a look at. Some of those is, the things are mutable. Date is actually really a date time. And there are also other classes for SQL. So there's a mixture of date times, dates for SQL, times for SQL. There's no time zone support, and it's not easy to use. Things got a little bit better when we moved to calendar, but it was still mutable. You couldn't format date directly, and performing arithmetic operations in terms of how humans would specify things, in terms of something is 2 months away from now, wasn't clear, or it's quite tricky to get that correct. So Stephen, I've got a bit of a question for you here, which is an example from Java 1 in 2008. How many bugs can you find in this datetime code?
How many bugs?
I'm bearing in mind it's only a few lines.
Okay, well, if I could remember the constructor for the date, I probably would be able to find a bug in that. But offhand, I can't remember the order of the parameters.
That's cool. So I'll skip on and show you that there's actually 6 bugs in this code.
Not surprised, yes.
It looks like on the face of it, it's quite a logical thing to do, but in this date constructor here, you've got 2007. Actually, the way that date constructor works is it's an offset from the year 1900. So this would be 1900 plus 2007 to get the date. This is actually the month here as well, is 12. In date constructor, that was 0 indexed. So that would actually be an invalid month. It'd be out of range. 11 is how you specify December. In terms of time zone, .get time zone, this is actually not the ISO specification of a time zone. It's got an arbitrary underscore in there as well, just to split things up. You've got a new Gregorian calendar here. You can't actually create a new Gregorian calendar. You have to use the instance methods on there, which makes it very difficult to sort of unit test and to mock out. And then you can't format directly a calendar object. You have to convert it to a date and then format it. Yeah. So this is just an example of a few things that are tripping people up consistently. So we're going to go through the basics. There's a new package in Java 8 called java.time. And we now have proper objects for representing date and time separately and together. So a local date is just a date that doesn't have any time attached to it. Simply a 29th of the 9th, 1984, which is my birthday. A local time is just a time, 1332. It doesn't have a time zone attached to it, and it's just a time. A local date time is actually a combination of local date and local time. And a zone date time actually starts to bring time zones into the mix as well. So let's skip to the IDE. I've got a few examples here that we'll go through. I've got some unit tests here to sanity check that what I show you is the truth. So how do you create a new local date? The first thing I did when I picked up this was go new local date. Actually, that's not allowed. Everything that we use in Java datetime is based on factory methods. So if we'd actually do this, local date of, it's very convenient. It's got like what you'd expect. You've got year, month, and a day of month that you'd specify. And you'll notice that you can actually specify the month as an integer or as an enum month. So in this example, we're going to do Henry VIII's birthday. So that was the year 1491. The month was June, and the day was the 28th. So that gives me a very easy local date, not specifying anything else that can now be used in code and understood quite simply. So what about local time? Well, again, you'll see that a lot of the constructors for making these things are consistent. So we're using of again, and this time I'm just going to use 1351, which is, again, you've got hour, minute and second, or hour, minute, second, and nanosecond. So this is an additional level of accuracy that's been introduced into the 310 APIs, nanos. So we're just going to specify 1351. We don't need to go down to accuracy. So now what about date time? So again, to be repetitive, but this is actually this is quite nice when you get it. IDE as well is quite nice for the autocomplete. Everything's sort of named nicely. So here we're just going to do a combination of the above. So you'll see that you can go pretty much left to right, and things increase in terms of their accuracy. So we can use 1491 month.June 28 1351, and we find out that I'm not using that properly. And then actually, well, would you want to specify that if you've got this stuff? You can actually do a local date time from. Actually, do I mean from? I'll just quit from, I still mean of. And we could just do here, get Henry's birthday and get sample local time. So that's another way that you could just combine them. So the of method really is how you would go about creating a date time. So what if you've got a local date time and you want to convert it to a local date? So if we do this, let's just create a local date time, and then we could do this now. So this is really simply how you just get what is right now, and then we could just do here to local date. So you've got the conversions here, so you can convert things through to easily convert between the two different types. And we'll go into some more of these in a bit, but to local date will work for now. So here I want to get the difference between a zoned time in Paris and London. So we could do a zoned date, kind of, if I could get, so zoned date time, and again we can use of. Actually, let's use now and then do with, and this is where I'm rusty, so I'm going to use my autocomplete to take a look through. What have we got on here? So this will be a nice time to actually go through what we have. So with is a temporal adjuster, and we'll go through that in a short while because it's a bit of an advanced concept. We've got until, so you can measure time periods as well. And what I actually want to do with this is find a way to use my zone. How is it actually in this now method? Hold on. Okay, this is where I skipped to my notes because I forgot. Ah, yeah, okay. So let's do Paris. This is what I was looking for. And here I could just specify my zone. So going back to what we had previously, you specify it in the ISO format. So we've got Europe/Paris. And then we'll do the same for London. I'm going to cheat and just copy and paste that. And switch this around. So we've got London and London here. So now we'll just find the difference between Paris and London. We could do just Paris minus London. Cool. Let's just run those unit tests and make sure that I haven't done anything silly. I have, because it doesn't compile. So here I just really want to find the hour. So I could do get hour. And these get methods are really convenient on these objects. You've got pretty much, you can get absolutely anything off there. It makes it very easy to read what you're trying to do. So if we just rerun those tests with hopefully the code compiling this time, we should see that they're all green. Phew. Okay, so let's just switch back to the slides, because now I want to talk about working with date and time. So I've just basically gone through some very simple bits and pieces. That's how you're going to create date times from now on in Java 8 if you choose to use them. So we've got to talk for about instant, duration, and period. So an instant is actually probably the closest thing to java.util.date. When you do a new date, you get effectively a millisecond value of where you are from 1970 from the epoch. An instant is exactly the same thing. It's just a point in time on the timeline. A duration is a measure of time. So you could take one instant to another instant and say that's 34.5 seconds. So that's just purely time-based. And a period is different because it's based on like what we would perceive as humans. So we'd be unlikely to say 5 days time to someone. I'll meet you at the pub in 5 days time is probably a reasonable thing to say as opposed to X number of milliseconds from now. So this kind of period certificate allows us to interact a bit easier with the API. It's also, the difference is quite subtle, but important when working with zone date time operations. So period will use details within the chronology that you're using, and for most people that'll be the ISO chronology, which is the standard date time calendaring system. So if you put the same amount of 5 days in seconds and it was going over a time zone, then you'd get, going over a daylight saving, then you might lose an hour. Whereas if you put a period, that would resolve. And java.util.date, I actually mentioned close to instant, and in Java 8, it's got a new method on it, which allows us to be compatible, and you just use toInstant on there to convert that into an instant, and then from there you can start using the new APIs. So I've got some second examples here, which we'll start to explore just working with these. So I'm just going to run my unit tests to check that everything fails and that we're all compiling. So start from something that we know is not completely broken. So let's just say is today after tomorrow. So we could create a local date today, and we'll just use local date.now for that. And then if we want to create a local date for tomorrow, then we could do the local date and specify the exact date for tomorrow, but we can actually do today dot, and there's these convenient methods on here for plussing, minusing days, months and years. So in this case, we just want to plus 1 day on. So we could do this, and then we could, to test if today is after tomorrow, we can then say, we can check tomorrow is after today. So that's a bit slightly the other way around of specifying things. You could also say today is before tomorrow. So these operations that we were talking about, it allows you kind of easier access without having to go comparing millisecond values and say, is this value in raw milliseconds less than this? We could also use, so if we wanted to find the last day of the month, this is again something that can differ depending on like what month you're in. Obviously, February's got 28 days, others have 31 and 30. So we can use a temporal adjuster, and I mentioned this briefly when I was panicking earlier. So if you do let's just say we want to find the day of week in the month. So we do local date, we say now, and then we can say with. And then there's these the concept is a temporal adjuster, and you can implement your own. But in this case, we've got a temporal adjusters, which actually gives us loads of handy things that you want to do date time. So we just say last day of the month in there. And now we've got our local date, we can actually just say get day of week. And that's just going to go to take the time now, and then the with will move that date on, and then the get day of week will get that date out. So now we're going to talk about the period class that I was mentioning earlier. So how many days is it until the longest day of the year? So if we do our local date today, and that's local date dot now, and then if we do take our longest day, and then we could do this of well, actually let's do the let's take today and adjust it. So we can do today dot with, and we can say with and do month dot June, and then we could say dot with day of month and do 21st. Cool. So that's our longest day. And then what we could do here is we could do period dot between, and then we start date is today, and then we'll go for our longest day. So, and from period we want to do get days. So you've also got on this period method, you know, we could actually say that we want to get the number of months, the years. Again, it's quite nice to, you can see this stuff very quickly when you kind of hit the dot. Oh yeah, these are all the things that I could do with that. So in this case, we want days. Now here I've got two date time zones. I've got one for Los Angeles time zone and one for Europe, London. And what I want to do is see in duration, how long is it until the new year. So I could do duration again dot between and say here and GMT New Year. Okay, and just to round things off, if I wanted to, if I created a new date, this is the old Java 7 way of creating a date. And then we've got this toInstant method that I was talking about. And then the thing to remember about toInstant is it's going to be in a particular time zone. Now, with that, you can do system default if you don't care. If you did care, you could actually specify a time zone here, and then from here you could do to local date. So this would be the standard way to convert from java.util.date to local date. Okay, so I'm just going to quickly run this up and make sure that we've only got this last test failing. I haven't done anything silly. What have I done with the test duration? So, yes, so this is one of my intentional issues that I've left in. You'll see here that what I've done is with this tends to happen sometimes with when you're trying to test date times now. You would say, I've got a time now and I've got some time, I want to measure what's happened between it. It might be you measuring some time for a trade to go through, anything, whatever it happens to be. And actually what I'm doing here is wrong. I'm doing similar kind of thing as what I'm saying now and then in the future measure a difference, but I can never make this test work because it's always going to rely on the time it takes to execute. So what you can actually do is when we did the dot now in the second example here to create this, you can actually specify a clock, and the clock, all methods would now take a clock. And the idea with that is that you can put the system clock in there for a standard for your actual main code. But then in your unit test, you can put a clock and you can fix a time to what you want. So you can actually start to mock the clock. And if you've got code that's that complex, then this is what you'd do. So for now, I'm not going to address that in this test. I'm just going to comment that out and cheat a little bit and move on to an example that's in a little bit more depth. So what we're going to do now is we're going to try and find out, given the months in the year, what are all the days, the last days of every month. So if I was writing this in Java 7, the first thing I'd be doing is, okay, I need to return a list. So I'm going to create my dummy list, and I'm going to say that that's a new array list. I can use my diamond operator. And what I say is, well, how can I iterate over the months? So I could do for month, and I could do month.getValues. Okay. And then what I need to do then is to take a local date and get it to the last day and then get the day of the week. So I'm going to create my local date, and we'll just call it date for lack of a better variable name. And we'll do local date now, and we'll adjust it to the year. So we'll take the year that's been passed into the method here, and we're going to put the month in as well, which is the month that we're doing in our for loop. And then we're going to use, I'll just put this onto the next line so it doesn't go flying off the edge. We're going to use use our temporal adjusters again, like we did in the example above, to get the last day of the month. And then we want to do get day of week. So just to walk you through what's happening here, actually that's a good point. That needs to be a day of week. I've gone too far. So what I've got is I've got my local date, and I'm just saying take one from now. adjust it to the year that we specified, give it the month, and then get the last day of the month and get the day of the week. So then standard here, we do list.add day. Everybody's happy, we return that list. So let's run that and make sure that there's no schoolboy errors. Okay, so we're looking good. But really, if we're starting to do things like this in Java 8, we've maybe not watched another video on how to do lambdas. So I'm going to just briefly discuss how I'd convert this into a lambda expression. So let's just comment this and figure out what we're going to do here. So we've got this list and we're creating a new one and returning it. Or we can get around that with using streams to give us our data and just return the result out from there. So we basically have to do the iteration over. So we need to get the months. So same as we've done in the for loop. We're going to need to apply basically a transformation to each item. And then we need to collect that into a list. Okay, that's doable. So let's just comment this out for now and we'll just keep it here in case we get stuck. So let's say, so first of all, we've got our month.values. So let's say there's a cool thing on streams, if I can spell streams, probably stream, yeah. So a cool thing on the stream API, which is just of. Now, if you're using collections, so if you've already got an array list, you can just do .stream. Here what we can do, because it's a primitive array, because it's an enum, we just do month.values. So this now gives me a stream to play with, which is kind of cool. And here what I'm going to do is kind of I need to apply transformation. Well, that sounds like a map operation to me. So I'm going to use a map on this. And it's a lambda expression. So what are we doing in each of these things? Well, we've effectively got a month. And to that month, we're going to apply effectively what we've got here. So let's just steal this code. So we're effectively going, just separate this out so it's not too bad and remove the comment. So we've got local date.now, same thing, exactly the same thing as above. And then finally, what we want to do then is .collect. Now, so we've taken a stream, we've got our data coming through, which is 12 months, we applied a transformation, and then we want to collect it to, and there's this cool thing called collectors, and this has some really useful things to collect things into. We could just do .collect to list. Cool. And obviously we would just want to return that. So looking at the complexity, we've removed all this boilerplate. We've removed having to create an empty array list, having to have these for loops. We're really just thinking about the data here, which is exactly what lambdas is intended to do. So it's quite easy to just refactor that, and I think it's slightly more readable as well. And if we run this, hopefully we haven't made any errors. Yeah, I was a bit nervous when it went orange there for a short time, but that's it, all tests passed. So that's a little bit more of how you can use, what I didn't mention was temporal adjuster is a functional interface, which is why this stuff kind of works nicely as well. Cool, so we talked about Java util.date. Oh, parsing and formatting. I'm not going to spend too much time on this, just to show quickly the features of parsing and formatting. So you've got this class called DateTimeFormatter, and it's just one thing that does so much. But it's also got convenience method on it as well, because usually you don't care too much about the format unless you're receiving some file from somebody that you can't go and hit if they've got it in the wrong format. So here we just got the nice defined pre-formatter ISO date. You can build a custom pattern, and I'll show a quick example of that. And all the objects, like we could use localDate.of and localDateTime.of, we've got a format and a parse. So let's look at that. So we've got our formatting examples here. We'll just run quickly the supporting unit tests as well. And if they pass, we worry. They don't. Cool. So we just want to format a simple date, and we'll use today. So let's do localDate.now and then format. And we'll use the ISO datetime formatter. So we just do datetimeformatter.iso. And that's it. Really nice. Same thing with if we want to specify a format, we could do now .format, date time formatter, and you can use this of, oops, it's got a bit carried away, of pattern. And here I'm just going to grab this pattern that I've got here. So the example that I'm passing in is month, day, year, specified. I think that's the American style. One thing just to note here with the previous date time formatters that we had, or the date format, is that some of these letters have been changed, and that's not to annoy people. It's to bring people in line. It's to bring the API in line with the standards that are out there for representing this. So just be careful if you try to port code straight over from a previous formatter. And then this one, we just got a local date again, and we can use a parse. And here, because I'm just using ISO again, I could just pass it a date string. And hopefully now, this just works. Yay. So this is, again, there's so much I could go into, but given time constraints, it's just worthwhile just showing these things. And you can actually, if you're looking at this before Java 8's launched, you could go and see the Java doc for this now, download.java.net, I think it's on, and you could just have a look, even if you don't have time to have a play, and just be aware of what's coming up. Certainly makes life a lot easier. Okay, I haven't got a slide for this, which is why that's just done that. I just wanted to talk about a few advanced examples. So I landed in San Francisco on Monday. I was quite surprised that it seemed like everybody was too busy to do stuff, and it's because banks and schools are on holiday. So I've written a few examples here to try and interact with the calendaring system for something that's not already specified. So 2 examples, we've got Martin Luther King Day, and we've got the quarter of a year. So in a lot of financial institutions, you need to know, is it quarter 1, 2, 3, or 4 for reporting purposes, and that's not something that's provided out of the box. So I'll just quickly go through a quarter of year. I have tests for these, but I'm not going to sort of code them up. So you'll see here that we're doing a query. So this is basically just saying we could take a date and we can perform a query operation on it. And we can write that query to basically be whatever we want. I've got this new quarter of year query here. Let's just put this down so we can see. And all I do is it's got this, it implements a temporal query interface, and you can basically return whatever you want. So that's quite nice, because if you wanted to return a list of something that was specific to your business logic or business domain, you can do that. You can specify pretty much anything. Well, you can. It's a generic. And then here we've got, so here I'm now overriding the one method in here, which is query from. I'm expecting this to be a local date. It could be, you could pass in a time, it will be a local date from that temporal object. And this is the temporal concept is something that's kind of a bit lower level. It's what kind of premise the local date, local time classes, which actually brings me on to a really good point. If you think about when you use array list, you normally use list on the left-hand side and array list on the right-hand side of the assignment. With dates, you use the concrete classes, because otherwise you get into a world of hurt, and it's clearer what's going on as well. So first of all, I just take this and then I go, okay, well, I'm going to write my logic now to say what this is. So I say now, which is just what this is, and I can just do my is before. And I take now, and I create the month of April, and I say with day of month 1. And then that just is then returning, it's the first quarter, it's second quarter, third quarter, fourth quarter. So I've added on to, I bolted onto the API something that's important to me, but if you didn't care about quarters of years, it would just be bloat to the API, which you had to be careful with. And this one is to find the next Martin Luther King Day. It's done in the same kind of vein. It's used, but using the query. So I do, I take a local date and do from temporal again. So I've got a date, and then what I want to do is I take the current year Martin Luther King Day. So I get current year Martin Luther King Day. I pass a year, and then I say local date of that year, January the 1st, and then I say this is a cool day of week in month. So you just do free in Monday, and that takes you straight to the third Monday in the month. You could also, if you didn't know what you were doing when you were writing this last week, you can use something called next or same day, and that means you can actually not know where you're landing in a calendar and say, if I'm on a Monday, don't go one further on, and if I'm on any other day, then progress. So you can actually use that to logically iterate over days that are in a calendar, which you might want to do if you were going to go over something here and collate some data and pass it back. And then what I do is I use the period class again. So I say period dot between, I've got my date now, and when's the current Martin Luther King Day. Now a period can be negative or it can be 0 if you're on the day. And then there's these handy methods of is negative and is 0, just to say, or there is positive as well. So you can use that to test without having to sort of use an integer comparison. And here what I do is I say, okay, if it's negative or it's 0, so I'm on the day or before the day has passed, then I want to find Martin Luther King Day in the next year. So I just recall my method, Martin Luther King Day in year, and just increment the year by 1 and then return it. Or otherwise it's we're between the third Monday and the beginning of the year. So I do that. So that's all the code examples I've got. One of the things I wanted to mention, if you've got this far and are still listening, you might be like, okay, well, this is all really cool if you're using ISO datetime, but what if you're using like another calendaring system, or maybe I want to write my own calendaring system? You could do that, and it's all supported inside the API, and actually Oracle provides a bunch of calendars for internationalization out of the box. So one of the hardest things about this API, when people say why has this taken so long, this is box standard stuff, is to write an API that supports the majority of users that will be using ISO datetime, but then also make it so it works and is workable for bespoke calendaring systems. It actually takes quite a lot of thought, and it takes a lot of trials to get that right. And I think that's where, when people say why is it taking so long, you can sit down and have a really long conversation about it in the pub until you drop off your seat. So that's all I have. Thanks for listening.